Okay, we've got a fun problem here today. This one's from Berkeley Integration Bee 2020 something, 2022, problem number 9. We have the integral from 0 to pi over 2, cotangent x, natural log, cosine x, dx. Okay, we have multiple methods on this one, and for this one, my starting point is going to be, I just want to multiply in by 1. I'm going to multiply in sine x over sine x. The thing to keep in mind with this is cotangent of x. This thing is going to be the same thing as cosine x over sine x. So when I multiply it in, I'm going to do it a particular way, trying to set up what I want to set up as a u substitution. So if I multiply in this sine times this sine right here, we get sine squared. Sine squared I can write as 1 minus cosine squared. Is that? Trying to create a bunch of cosines. We have cosine there. We're going to have this cosine in the numerator. Okay, so write this part, but then I haven't done anything with this one, so let's have this sine over here. We'll just leave it. I'm not going to multiply it in yet. And doing it this way with all these cosines, now it's in pretty good shape for the u sub. So we'll set our u equal to cosine x, and then if we do du, we're going to get back, not quite sine, but we're going to get minus sine x dx. Well, that's no problem. I can just multiply in sine right here, so I don't change it. Let's just change it right here. I could bring it up front, but let's just do it this way. Reverse the sign there, so that way that all cancels to a 1. Then when I substitute, plug in pi over 2, cosine of pi over 2 is just a 0. Cosine at 0 is going to be 1. Then for all this business here, it's going to be u. We'll kind of reverse it, write this as u squared minus 1. I don't think I wanted to do it that way, but I can fix it later. And then, okay, so this is going to become natural log u du. Yeah, I think let's put this back. I don't think I wanted to do that, so I'll write this as 1 minus u squared. I'll leave a minus here. You might want to flip the bounds. I'm actually going to just leave it for now, and you'll see why in a minute, but we'll just let that be. I'm going to do another substitution. I just want to clean up this. So what we'll do on this one, now we'll use t, using a different variable, so we'll have, I'll just do t equals u squared, then we'll do dt, take the derivative, is going to be 2u du. I can create a 2 by multiplying in a 2 right here, so that this part's going to be our dt value. So that I'm not changing it, let's multiply by a half. Let's kind of, here I'll fudge it this way, we'll turn that into a half, but keep the minus sign. Then one other little thing I can do in order to deal with this u right here, I'd like it to be a u squared. I mean, we could do it a bunch of different ways, but let's just kind of force that to be a u squared for our substitution. If you think of what would happen if you pull it out front, we're actually like multiplying by 2, so that I'm not going to change it. Let's multiply by another 1/2. Then I'm going to eventually bring out front here. So hopefully you'll just see that that 2 times that 1/2, we're just multiplying by 1. Go ahead and substitute. We'll multiply these together now, so we're going to have minus 1/4 in front. Going to leave the bounds 0 to 1. The reason, if you plug in 0, you get 0. You plug in 1, you get 1. Like I said, this stuff here is going to be our dt. So we'll move the ln in. It's going to become natural log of t, because we set it up, over 1 minus t, and then everything else is just dt. But now the reason for the weirdness and getting it in exactly this form is because this is set up for me to use the Dilogarithm on it. So now for the whole integral, we can just use a formula. Let's take a look at that really quick. Now looking at this thing here, you can probably see why I wanted to keep the lower bound as 1 just to match this formula here, right? Because we get the 1 there. The input into the Dilogarithm is just this z value. So this is being dictated. So this thing right here is going to be all about this, because everything else matches. It's just a different variable. That doesn't matter. So this whole thing is going to be Dilogarithm 1 minus, plug this value in here, plug in a 0. Dilogarithm 1 minus 0. Of course, that's just Dilogarithm of 0. No, that's not. That's wrong. That's bad math. So this thing, obviously this thing is going to be Dilogarithm of 1. But Dilogarithm of 1, this has a well-known value. I've done this out in a previous video. This value is going to be pi squared over 6. If you want more information on the Dilogarithm and where some of these formulas are coming from, check out the playlist. I'll provide that in the description. You can go through this. But now we're just going to use this value and multiply it out to finish it. So we got pi squared over 6 times minus 1 over 4. And so for my final solution on it, we just get minus pi squared over 24, and that's it. Okay, so there you go. Fun problem from Berkeley Math Tournament 2022. Thanks everyone for watching. Have a good day.